All right, hi everybody. So in this case right here, we're just being asked to apply a couple of transformations to this function right here, the absolute value of x plus 1. Now, on purpose, there's been an addition of just a very slight translation here so that the function is a little bit more complicated than just that base absolute value here. It's going to stretch horizontally by a factor of 3 and vertically by a factor of 2. Okay, so what I think we should do here is let's use function notation. Let's maybe call this f of x. And let's apply the stretches to that function notation. A stretch horizontally by a factor of 3 horizontally goes within the function here, and a stretch by a factor of 3 means that I'm going to multiply x by 1/3. Now, and my reasoning for that is because if I now wanted to isolate x, I would have to multiply by 3. Okay, so that's the way I get that to work here. And vertically by a factor of 2, okay, vertically by a factor of 2 over here, means that I would be multiplying the function through by 2. To get y by itself, I multiply by 2, so I put the 2 over here. So this is what this function notation should look like. Now, f of x is this whole thing though. It's not, whoops, sorry, you can't see that. It's not just the absolute value of x, it's the absolute value of x plus 1. So first of all, that 2 sits outside that whole function. So there's that plus 1 here, then the absolute value. So the 2 is going to be distributed to both those terms. And then I plug the 1/3 x inside the function. Then I replace the x. And now it would be smart for me to do this, to distribute that 2 through. So this becomes 2 times the absolute value of 1/3 x plus 2. There is a little bit more that you can do with it, but I think that's the clearest way to handle that problem.